Alrighty. Good morning. My name is Jeff Keister. Today we're going to be talking about the PADS Professional Suite. I'm going to go over a PowerPoint, and then we'll be showing you a video of some of the functionality within the PADS Professional tool. So let's get started here. So, my name is Jeff Keister again. I am the application engineer for EDA Direct. We are the local distributor for Mentor Graphics plus other tools in the Bay Area, also down in Southern California. So should you guys need any kind of engineering software, we would be your contact. And so today we're going to be talking about the PADS PADS Pro product line. So we're going to go over a lot of the functionality of the tools and the options and what's available. So within this PADS product creation platform, there's going to be a lot of functionality that comes with this tool. So you're going to be able to have component management software. You'll be dealing with PartQuest and DX Databook. You'll have a schematic flow of either using OrCAD, or you can use Logic or DX Designer to bring in your schematics. We can also manage those constraints inside the schematic as well. So we've got a constraint management tool that's going to allow the engineers to put in their constraints, whether there's the differential pairs, setting up their match length lines, impedance control lines, what layers routes are going to be on. So we've got a full constraint management tool there. You'll have layout and route capabilities. What's also nice, you'll have the sketch routing capabilities that are going to be in this tool. You'll have 3D capabilities to allow you to look at the design in 3D and manipulate it, as well as in pushing this into the mechanical group. And then you'll also have some of the hyperlinks tools. So you'll have thermal analysis, and you'll also have signal integrity pre and post. So that engineers can actually create models inside of hyperlinks, simulate those models to find out if they've got timing issues, impedance issues, as well as after the board's been laid out. There's also capabilities that come with the tool that are added on. These are extra options that are available to you. You've got a multi-trace router, which allows you to route multiple differential pairs or match trace lines, and then tune them all in one easy push button. We've got an electronics cooling flow-therm tool to work with your mechanical group so that they can see the airflow and any hot spots that we might have within an enclosure. You've got the MCAD, MCAD collaborator that's going to allow you to talk back and forth with SolidWorks and Pro E. This is a nice little tool to be able to talk back and forth with them rather than sending them DXF files or IGES files. Here we can pick and choose what we want to send over to the mechanical group. And then you've got 3 more hyperlinks tools that have been pulled out of hyperlinks and positioned so that people can purchase these rather than purchasing the full hyperlinks tool. So for those of you that are doing DDR analysis, DDR 1, 2, or 3, we can do DDR analysis in the tool. We've got an electrical DRC. This is much different than the DRC that's run in your tool, where it's just more of a connection and a clearance violations that it's looking for. This tool here is looking for impedance control problems, traces that go over multiple power planes, metal areas that might be floating on the board. So this is more of an electrical check than it is a constraint management check. And then you've got DC drop. So DC drop is going to allow you to be able to look at your voltage planes, all your power planes, for example, make sure that you have enough metal so that you've got enough currency running fully through the whole plane. So this will help you to find out where you might have some hotspot problems with your power planes. Okay. So one of the first things we need to talk about is libraries. And when you're coming in with this tool, you're going to need, to be able to create libraries, have libraries, convert your old libraries. But one of the nice things is for those that are starting out with this tool and that have no libraries, we do have the options of allowing them to get started with libraries that we have already. So you can go to the pads.com site, and on that there's a download from a company called ODA. That's Optimum Design Associates. They're in the Bay Area. they gave Mentor 10,000 library parts. ODA is a service bureau up in the Bay Area that also manages a lot of companies' libraries. So with engineers coming up to speed now and laying out their own boards, we're starting to see where they need help with their libraries because they don't know how to build their library parts. They don't know what's entailed with their solder mask, how big the pad should be, all that stuff. So you can go to these companies like these third-party companies who already build library parts, and you can download or purchase them. Another thing that we have available is you can use the PartQuest capability. It's really quite easy to use. PartQuest is tied in with the DigiKey catalog. So there's over 800,000 parts there right now that you can just pull in. It's really easy to use. When you're searching through the website, it's easy just to go ahead and join this this family of people that want to be able to pull off parts from this catalog. When you start to see this lead-free and this RoHS compliant, when you're looking for symbols, if you see that marked, then that means that we can download those parts directly right into our library. And what's nice about that is, and not only are we going to get the foot patterns built to the IPC standards, you're also going to get a lot of the properties that are already attached to it. So you have package type, the symbol that's available, how much is pricing, quantities, minimum purchase. So there's going to be a lot of properties that are already associated to this. You'll just have to add on to those properties that you require within your company. What's also nice, and this is new, Mentor's always had a component and a cell generator, what's inside the tool, but now instead of leaving the PartQuest tool, you can actually now go in and create your own schematic symbols or your own footprints. So we've actually put the symbol creators inside of the PartQuest to allow you, so you don't have to be back and forth inside and out of pads creating those symbols. You can be in PartQuest, create the symbols, and then push them right into your library. What's also important to note is with using our tools with the PADS Pro, you're going to have a central library, a little bit different than your PADS library, but we're going to be able to maintain this library, and all the data is very consistent inside of that tool. So having this central library is going to allow us to be integrated into our schematics, into our constraint management tools, into our layout tools. So it's easy for us to be able to go back and forth in those tools using this one central library. Now, schematic design is, you can either use your OrCAD if you'd like, you can use Logic and stay in a netlist flow, or you can go ahead and use the DX Designer flow if you'd like, which is going to give you a lot more power using this professional tool. You can stay with the netlist flow, but to really get the bang for the buck, you're going to want to move to the DX Designer tool, to give you hierarchical design. You're going to have constraint management definition inside of the schematic, which means we're going to be able to put all the constraints that we want inside the schematic and then pass that to the layout group without having to put little post-it notes and things like that. So this is much more appropriate for the designers to be able to put those notes in, pass it to the layout guys, and they can continue on working. Should you have to make changes, you can always go back and forth with the constraint definition tools. There's going to be a component management tool as well, which is going to manage your library. It's going to make it very easy for you guys to search for components. And then we also handle variant management. For those of you that are not sure what variant management is, that's if you have like one motherboard and then you populate it different ways to create different products. We can manage that by creating your BOMs and your schematics very quickly, easy, removing the manual process of that. So all those features can be pulled into the DX Designer tool, on top of all the other features that are available with that tool. And now, component management is going to be pretty important because we're going to be able to manage all of your library parts, all of your properties in one location. So what's nice about this tool is you don't have to know what all these different properties are. We can actually tie into different departments within your company whether they're using Excel or Access databases or SQL databases, whatever they're using, and we can actually take information from their spreadsheets and pull those into our spreadsheet so that we can use those properties and associate those to the components. So we have a really nice component management tool. This way it makes it a lot easier for engineers to be able to look for the designs and the parts that they need right inside of the tools. Okay. Pre and post signal integrity analysis. Now this is going to come with the tool. This is really useful for engineers to be able to handle a lot of different functions. Now what's nice with the PADS professional tool is you're also going to get a PADS AMS, an analog simulator, very much like PSpice, much better. So what I like about it is when you're in this tool, if you create models and create what if scenarios, you know, we don't have to recreate those into the DX Designer tool. We can actually just grab them and push those right into the tool. So we don't have to redo everything. So we have a nice little analog simulator that's going to come with the tool. You're also going to have pre-layout analysis, pre and post. This is going to allow you guys to be able to come in and push your design, your schematics right into hyperlinks. We can check for ringing or overshoot. We can create IBIS models and create what-if scenarios. We can come into the layer structure and set up our layer structure in here, the board stack up, thickness, pre-preg, what materials we want to use, impedance control layers. So we have full control over our layup and everything that we want to do inside of the SI tools. Also, you're going to have able to do layout after the board's been laid out. So maybe some of you send your designs out to service bureaus and you want to check to make sure that the signals are correct. Or maybe you have a clock line on there that you want to check. So you have full verification to check for EMI, crosstalk, impedance control, even after the board's been laid out. So there's your pre and post signal integrity tools, as well as thermal analysis. So as long as you're putting in the properties for the temperature range, we can come in and we can check to make sure that where our hot spots are on the board. We can find out if we need to put in heat sinks, maybe some mounting holes to cool in that area. So you've got a nice little thermal analysis tool as well. Okay, the constraint management tool that we talked about. Now this is something different than what you've been using on PADS, where you have all those pull-down menus and all that. This is more of an easy Excel kind of a spreadsheet. You can see everything that's going on rather than all the pull-down menus when you were in the PADS tool. So what's nice is there's a single location. I can come in here. I can set up all my different classes very easily. I can set up all my constraint classes. I can see exactly what I've done in here, setting up my widths, my layer structures, the vias that are going to be routed, what layers things will be on, what nets get to be routed on what layers. So all of your constraint management is going to be in this tool. And what's nice is that you'll have access to this in the schematic as well as the layout. So should an engineer start to put in maybe constraints in here that you don't agree with, or maybe you find out you can't match, you can always edit those constraints and then back annotate those back into the schematic. So you have full capability of back and forth annotation when you're dealing with the constraint tools. Layout and route. Okay, so what's nice with this tool is we've got a lot more capability because you're dealing with expedition, okay? So what's nice is, for example, the planning and the placement of tools. You know, in PADS, you've got all the components. They're on the outside of the board. Well, here we can take things a little bit different. We can actually set things up in our schematic, set up clusters per page, and then when we bring those sections in, maybe like a buffer section or a memory section, we actually can bring those in so we can kind of do some kind of a planning on here. And then all the parts will be inside of that circle. So it's easy to be able to pull those right out. So this is really nice in helping you plan your placement on your board. You're going to see a bigger difference than what you see in the PADS tools. It's going to be more of like a hierarchical group. What it'll be is you'll be in the schematic and you'll set all the parts that you want to be associated with that, and then you'll just set up a cluster and then give it a name. So this one's called reuse. These are all the components that are on the schematic, and you can see that they're all tightly inside of this circle. That way we can now drag that reuse and then pop it onto our board. You're also going to be able to mark and drag and drop and see more of a spreadsheet personalization of your tools, of what parts you're going to have on the board. So not only are you going to know what parts go in what sections using that the clusters, you can actually see what the parts are, the names of the parts, what nets they go to, what cell they are, part numbers, everything like that. So you'll be able to see this in the Component Explorer, which is really nice. And there's a filter in there that allows us to turn things on and off. So if we want to see the pin numbers, or we want to see the reference designators, you know, or mark which parts are marked and which ones aren't. So you've got a nice capability inside the Component Explorer. And then you're going to have routing. Okay, you're going to have a lot of the capabilities that you had in the pads tool with the push and shove, routing differential pairs, the accordions. You'll have all those kind of capabilities that you'll have in the layout and the route. And you'll also have a lot more. So you're going to be able to do cross-probing between the schematic, the board, and the constraint editor. You'll be able to have physical design reuse. So should you have signals that you have designed on another board and you want to use them on the board that you're laying out, we can actually set up those designs and create reuses. We're going to have the variant management, which I talked to you about earlier, creating one board, a motherboard, and then populating it different ways. So you're going to need to be able to manage the schematics and the BOMs and the layout. So we can manage that. We've got plain and copper creation manipulation, so we can push and shove inside without having to do copper pouring all the time. And then you'll have interactive high-speed routing, which is going to allow you to be able to route your differential pairs, put in accordions, route impedance control lines, match length lines, push and shove. So you have all those capabilities inside the tool. But what's also nice is you're going to be able to have this with the Component Explorer. You're going to be able to see in your display areas very easily which components are going to talk to which components, and then there's a net visualization that you're going to really like. Before, when you're like zoomed into an area, you can actually see the RAS nest cover the whole area. It's very difficult to kind of see where the connections are. Well, now with a dynamic filtering in here, what we can do is, as we zoom in, whatever's inside that window will only show where the missing connections are. So only within inside the window that you see. If you zoom out, more connections will show, but only as they pertain to that window. So it makes things like not easier, a lot better organized when you're designing and routing. And the big feature that you're going to get is you're going to get the sketch routing capability. Okay, this is a lot different than auto routing. What's nice is you're going to be able to escape your VGAs very easily by fanning out. It's completely user controlled. We can decide where we want the routes to go and how we want to route them. We can set up the via patterns as well. So this is a very powerful tool, and we're going to talk a little bit more about this as we go through this PowerPoint. So sketch routing, it's not so new technology. It's been out for a couple of years, but you can see how easy it is to use. So basically, you're going to be selecting the nets that are to be routed, and then you're going to go ahead and stitch in how you want those routes to route. And then as you turn on the sketch router, it will automatically look at the connections, untangle them, and then route them exactly the way that you wanted to route those signals. Pretty easy to use. Basically, it's all user controlled. You select your nets. For example, we'll select those nets and then tell them we want them to route this way, and it'll route those way nice and packed. We can route them also with vias, see how the vias are. And what's nice is we can change our via patterns as well. So we've got all kinds of things that we can change, set up in here, whether you're routing your differential pairs, how you want the pads or the traces to be routed into the pads. We've got Z-axis rules, and everything works with the constraint management tool. Now, what's nice is, what I like mostly is when I'm dealing with a bunch of BGAs and components that are going to talk to each other, what's nice with this algorithm here is it does a lot of entangling. So once you see, in the example here, we've got a lot of lines that are crisscrossing between each other. Once we run the sketch router to make these connections, it's going to untangle these automatically for us and allow us to be able to put as many traces as we can on one layer. This one here is, enabled this without any vias. And there's two kinds of routing methods, okay? So you can either have packed or you can have unpacked, okay? You can either route with the vias or route without vias. So in this example, you can see here, we've got everything nicely packed, and then we have it here unpacked. Same thing for here, nicely packed lines. This is nice, but maybe if you're doing differential pairs, you want to have them unpacked, spread things out a little bit. So you can see the differences between packed and unpacked. And then there's the via patterns. You're going to have 34 possible combinations of via patterns. Okay, if you'll notice here, as this is routing, you can see how these vias are set at a 45-degree angle. It's very easy to change those as well. You can just come in, select that net, go ahead and then use your right mouse button and you can change, do you want it to be a single row, a double row, what angle do you want them to be on? Do we reverse them? So there's all kinds of options that, and all kinds of possibilities that we can set up so that we're not blocking off those channels when we're routing these designs. So this is something you'd want to lay out first before you start to go into the other routes. Okay. The quality of the routing, though, is phenomenal. I have to admit, the differential pair routing is unbelievable. I really like this router. It maintains the spacings. It does a great job from BGA to BGA. It's very easy to edit, very easy to push and shove. Here's an example of two BGAs. I don't know if they're like 1,500 pin or 2,000 pin BGAs. And they basically selected all those nets, and then they're going to just go ahead and route this. And you can see how, the real time of what it was routing at, how quickly it does. So within 5 minutes of this layout, we've basically laid out and routed all those traces that are going in between the two chips. So within 4 minutes and 52 seconds, it's routed 306 lines, and that's basically a line per second. That's pretty good. That's pretty good when you're routing a bunch of those lines and you've got like 15,000 connections you've got to do on a board. This is really quite a time saver. So in conclusion of the sketch router, you're going to be able to, it's going to be able to merge your auto routing and your manual routing. It's all in one, so it's more intuitive on how you want to route things. You're going to be able to control your routing. You're going to be able to control your via patterns as well, so that you're not blocking off channels. You're going to find that you can seriously route much quicker using the sketch router than anything that's out there on the market. Okay, and now we've talked to the sketch routing, interactive stuff. Let's talk a little bit about the 3D capabilities that come with the tool. So what you're going to be able to do is split your screen. It's just like pads. You'll have a 2D window. You'll also have a 3D window. It will have its own GUI. It'll have its own display layers as well. So we can turn things on and off, import step models into our design. We can measure. We can do electrical or 3D DRCs as well in the capabilities of this tool. So what's nice is for those people that like to design in 3D world, you're going to have that option. So you can either place parts in the 2D window, or you can move those parts in the 3D window. It's up to you. 3D gives you a little bit more of an idea of what's going on, but a lot of us, like myself, have worked on these 2Ds, and I just prefer this way. But you definitely can place parts in the 3D world. We're also going to have a 3D design rule checking. So should you bring in the enclosure from your mechanical group and bring everything that you need to put this design together, we can actually run DRC checks on here to find out, do we have problems between the height of the enclosure and the top of the components? Do we have problems between the edge of the board and components, or components against its components? So you've got a customizable 3D DRC that you can set up in here. It's easy to use, it's customizable to you and to your constraints. So very easy to set up. Then you're also going to be able to look at the design, a nice transparent, 3D capability of being able to see exactly what this thing's going to look like. So the photorealistic realization is a pretty incredible once we've got everything and all the step models engaged with the parts. But what I like is we can also take this design and we can actually increase the thickness of it so that we can actually see the barrels of the vias and the components to find out if we've made those connections. So you can cut the planes, increase the thickness size to be able to see how your connections are being done, whether you're doing blind and buried vias. Maybe you want to check to find out if you've got, anything's missing internally, planes, copper. So that's really nice. And then you're going to have a measuring tool inside of there. So once you've got this in the 3D screen, you can actually use the rulers that they've got and measure from one component to another. Maybe you want to measure the face of one adjacent to the pin location. So there's all kinds of, whether it's an axis or an edge or a face or a point, you can just go ahead and click, and it'll give you the distance between those points. You're also going to be able to import and export step models and create documents, so PDF files and things. So you can import like the enclosure from your mechanical group and bring it right into the PADS Pro tool, whether it's an enclosure, a bracket, components, as well as we can export the whole thing as a step model and send that over to the mechanical guys as well. So you've got full capability of importing and exporting, and you're also going to be able to create PDF files. So what's nice about this is we can create PDF files to allow us to send these to meetings, for example, or to our customers, or to anybody that pertains to needing to see these. But what's nice is they don't have to see the whole design. They can actually just look at the PDF file. They have full function to be able to turn off things that they want, rotate it, check to see how this board is going to appear inside the enclosures. So you've got a nice little capability with the PDF output. You're going to have a manufacturing prep tool. So this does not come with the PADS tools, but this does come with the Pro. So you're going to be able to create your drill drawings in here. You're going to be able to set up everything for your design rules. You're going to be able to panelize if you want to panelize, set up your thieving in here, create all your documentations, as well as being able to do DFT. So should you need to do electrical test, set up your probes and things like that, locations, you can set up all of that stuff in the manufacturing preparation tool called FabLink. There's also a drawing editor tool that comes with this tool that's going to allow you to be able to create all these documents that you need. Then what comes with it also is an archive management tool. So this is going to allow you to archive your databases, your Rev A's, your Rev B's, your prototypes, anything that you want to archive into this archive management tool that we have. It's going to allow engineers to actually go into the tool when you are, without a license, and they can actually cross-probe between the schematic and the board. Inside this tool, they can do what-if scenarios, maybe see the difference between Rev A and Rev B and see the graphical changes. They can put in post-its if they want to remind them when the board's ready to spin, some things that they might want to change. So you can track not only all the designs, but all the different versions, create what-if scenarios. So a nice little management tool that allows you to be able to store your databases. And then we have the capabilities. So these are the options that are going to be able to come onto that you can add to the tool. So you're going to have like we talked about, the MCAD collaborator. So this is going to be able to talk back and forth between SolidWorks and Pro E. It works really easily. You'll have your design in 2D. You've got a design in 3D here. And then what will happen is you're going to use this collaborator window. This will pop up, and what we're going to be doing is sending over what's called IDX files. So we would pick and choose a directory that me and the mechanical guy want to work with, that we're going to send data back and forth to. And then I would create a baseline of that design. And so what's nice with all these collaboration data in here, all these pull downs, I can actually pick and choose what I want to create. So if I don't want all the 0402s and the 0201s and all the small components, I can go in here and turn all those off. I also can be able to take the top and the bottom layers. So that way the copper that's on the top and the bottom can go to the mechanical group. That way they can see if the enclosure sits on top of those. So this is really nice. This is not something that we've had in the past. So what's nice is to be able to take these traces back and forth between you and the mechanical group. So once you've done that, the SolidWorks people, they're going to read this into CircuitWorks and then go ahead and build a model. Once they've done that, they're going to push this into SolidWorks and then create what the board's going to actually look like in SolidWorks. Now, what's nice about this is, should the mechanical guys decide, they don't like the location of some of the components that the PCB layout team did, they can actually go in and move these components to the correct locations that they want them to be in, and then we can go ahead and back annotate that in using the collaborator and then bring those back into the pads tool or the Pro tool. And then what will happen is, if there have been changes, the parts will start blinking, and that lets you know that either we need to approve those changes or disapprove them. And then, so this is a way for us to go back and forth very quickly and easily with the Pro and the SolidWorks team. Okay, you're also going to have a multi-trace high-speed router. So if you have lots of differential pair lines that you want to auto route, or match length lines or min-max length lines that need to be routed and tuned automatically, we have a nice little tool for that, very easy to use. You're going to have DC drop. So in here, this is going to be able to tell you, do we have enough voltage that we've got running through the planes in here? Where might we have some problems? Maybe we need to add more metal, more copper, more whatever, aluminum, whatever you're designing with, to create it so that we have enough current and we can see how the current's running through the design. You're also going to have DDR analysis. So if you're doing any kind of DDR 1, 2, or 3, we can actually set up what if scenarios in here. We can set up and check for overshoot and undershoot, timing issues, data bus margin. So there's a whole gamut that we can run through in here to check to see if things are going to work before we even lay the board out. And then you've got the electrical DRC. So here we're going to be running EMI and SI and PI as well, all kinds of checks that we can run on the design, which is not the same as what you would run on your DRC, for in your pads tool, which is basically checking for spacing and connections. This is going to be for checking for traces that might go over multiple power planes, nets crossing gaps, metal areas. You might have crosstalk coupling, differential pair impedance problems. So this is going to look through your design and find those errors for you quickly, and then you can update your design. So this is a pretty powerful tool, and I highly recommend everybody using this DRC tool. Also have the flow term capabilities. This is usually used with the mechanical guys. So should they have the enclosure and the boards inside here, we can actually check to find out how air is going to flow, thermal analysis problems that we might have. So this is something that the mechanical guys might be interested in using. We also have RF capabilities. So you guys we're tied to the Agilent ADS or AMS. So we can tie in with those tools to do the simulation. We can reuse RF circuits on different designs, which is really important because once you've completed an RF circuit, you're not going to want to be changing that too much. So we can actually reuse those and bring those in. And then there's also going to be flex. Now I'm showing this to you because it's going to be happening in March, but we're going to have full flex capabilities in the pads tools, which is going to be really nice. So look ahead to the VX.2.3, where we'll be offering those, and this will also be able to tie in with the collaborator, so we can actually bring in all those flex designs right into Pro E or SolidWorks as well. So in summary, there are 3 basic tools that are coming out of here from the Mentor products. You've got the Standard Plus, and the Professional. What I like about the Professional is not only when you buy this tool, you are also getting, whether Logic, you're going to get DX, the AMS, but you're also getting all of this stuff, the Standard Plus tool. So you're basically getting 2 tools for the price of 1. You'll get Standard Layout, Pads Plus, and all the capabilities that come with it, and you get the Pads Professional tool, and they're going to throw in the AMS analog simulator as well. So this is a really nice tool to be starting off with, and it gives you that flexibility of going back and forth with pads. So before I finish my PowerPoint and we move on to the demo, there's some content that I like to let people know about. So there's a lot of content that's on the web, and it's definitely something that you guys should definitely look at. One of the things is there's going to be on-demand training. So when you purchase the software, you will have 30 days free on-demand training. So for the first 30 days, go for it, have a good time, try to learn as much as you can. Should you require that you need this on-demand training, more of this, there's a subscription fee of, I think, $900 for the year, and then you'll have access to this anytime that you want. That's one way to learn how to use the tool. Another way is there's also Mentor Graphics has a YouTube page. So if you go to there, do a search on Mentor Graphics YouTube, it's going to take you right to the page. And there's all kinds of videos in here, whether you want to know about Pads Plus, want to know Pads Pro, how to migrate, how to do things. So they've got a nice little YouTube page, as well as you can also go to pads.com. So you go under the resources, there's all kinds of videos to learn about the products, how to do things, variant management, for example. If you don't know how that works, they can definitely teach you this in all these videos that they have. And then there's an eval guide. For those of you that want to play with the tool, we can set you up with a 14-day eval guide. It's going to take you step by step through on how to use the tool. And I'll go into that here in a few minutes here. So that's the end of my PowerPoint. I'm going to do a little bit of a demo here, but before we do that, I want to talk to you a little bit more about the functionality of being able to get this content. So one of the things is you can go to pads.com. Here you'll be able to see all the products that are available, all the options. But over in the resource area, there's the videos in here. And you can click on that, and this is going to take you to all the videos that are available to you inside the tool. Okay, whether you want to know about layout, and it'll give you everything you need to know about layout, RF. If you want to talk about RF, we've got videos for that. So all kinds of videos that are available in here on the Pads tool. And then as well as the Mentor Graphics YouTube page. So do a search for it. I think it takes you right into Expedition, but we can click on this and take us right into the Pads tool. And inside here, there'll be a whole bunch of videos, stuff that'll start up. And you can look at how-to videos, Pads Standard, Pads Standard Plus, Pads Professional, migrating, library management with PartQuest. So there's a lot of information that's online that I want to let you guys know about. And there's also is the eval guide. So with the eval guide, when you guys, you'll ask your salesman for a host ID, they'll get you set up for an eval guide for 14 days. And you can go ahead and play with this tool. This is going to teach you everything you need to know about how to use this tool, and it will always be maintained on your hard drive. So whether you buy the software and you want to be able to come back into here, you can do that. So it's an easy tool to use. Very quickly, we can come in here, create placement. This is going to tell us where to go to, what lesson plan to use, and it's going to give you the step-by-step instructions on how to place the parts and how to do that. If you wanted to know about variant management, it's going to take you step-by-step on how to do variant management. So it's pretty well set up in here to be able for you to be able to learn everything you can right in this eval guide. And it's nice that you can refer to it as well. Okay. So before I do the demo here, I'm going to unmute anybody. Do we have any questions does anybody have any questions that they want to ask before we move forward? No? Okay, well then I will
Yeah.
mute everybody, and we're going to go ahead. Okay. All righty, so let's go ahead and start this video.
Welcome to the Pads Professional Overview.
where you will see many of the advanced feature sets that will enable you to address your most complex of design challenges. And they are available today. Why wait for solutions from Altium Athena or Altium Designer 18 when PADS Professional is available now? New functionality, including OrCAD schematic and netlist-driven PCB interface, provides even more flexibility and allows you to take advantage of the advanced PCB layout functionality, including 3D placement, routing technology, RF design, flex-rigid PCB design, and more, while maintaining your front-end system of choice. No need to retrain all of your design engineers. Mentor Graphics, a Siemens company, now offers PADS Professional key and netlist support. Use an ASCII text file to drive professional layout from many tools. Some of the largest designs we see are actually driven by key and netlist, where the design is too complex to describe visually as a schematic. For new designs, however, use the integrated PADS Professional flow so that you can take advantage of cross-probing and front-end schematic constraint entry, among the other advantages and features of PADS Designer. The PADS Professional GUI has been optimized for usability, speed, and user customization by providing user-tailored display schemes. Simplify your working environment and create a personalized display scheme based on the task at hand. By starting with a standard template, you can define your own custom toolbars and default object visibility settings. In this example, enabling part reference designator and part pins, one can place and route without switching display schemes or commands. It's just a single click. By setting up your own toolbars, commands, and object visibility, you can personalize your environment to your heart's content, creating a highly intuitive, tailored environment for how you approach PCB layout. You can change toolbar content and location by saving this information to your display scheme. Schemes can also be saved externally to be shared with other users. The purpose of a display scheme is to simplify your working environment and design flow, with display schemes independently control visibility and selection of task-specific objects, such as routing and fabrication objects. Filter out the unnecessary objects and commands so you don't have to fiddle around with the GUI. You can now spend more time using the tool and not fumbling around with the GUI looking for that one setting or switch. Make sure to take advantage of setting up your display scheme's favorites bar. Set frequently used object settings to the top of the GUI in your favorites section in order to organize your workflow for quick access. Take control of your workplace by color-coding specific nets and net classes with individual trace, pad, and plane controls per layer. This is extremely useful for quickly visualizing ground, powers, and critical nets during breakout and floor planning. Declutter your workspace by hiding little-used objects within your task-specific scheme. Just right mouse button click on a display control object. These hidden objects are saved along with each display scheme and can be re-enabled with a toggle switch. The point is to minimize the number of objects you need to hunt through. If you can't remember where the exact object setting is, you can just start typing into the display settings to search through the object list. Hit enter to go through to the next object. So why spend all this time creating custom display schemes? PADS Professional uses a context-sensitive select mode to drive operation of the tool, reducing the number of clicks in day-to-day usage. Depending on your task, you want the right objects visible and selectable. So a few hints of the tool. Use auto-hide windows to maximize screen real estate. Keying commands can be accessed by just typing. Command suggestions are visible at the bottom of the dialog and update as you type. A few really useful commands are MS for move selected by coordinate, and PX, place snap point at exact coordinate. Strokes are really useful. Strokes, right mouse button drag, are available to be customized. A few helpful default commands are diagonal down to zoom in, or diagonal up to fit the board. Drawing an L launches display control. And again, all of these can be customized. Dim transparency mode allows you to graphically control dimming and transparency intensities on unselected, unhighlighted objects, while displaying all selected and highlighted objects at full brightness. These modes are especially helpful in tracking down the physical topology of a trace when cross-probing through a very dense area of the board. No longer do you need to disperse components at the board edge and drag them on. The circuit engineers can create component groups in Designer, which the layout designer can place, append, and use as guidance during floor planning and placement. You can quickly view, sort, and organize a list of the relationally structured components, preserving the engineering design intent to guide placement. You can quickly append these layout groups and create new hierarchical planning groups as you deem necessary during the planning phase, and push that information right back to the schematic. Component Explorer is a spreadsheet interface used during component placement that drives all placement and planning with PAD's Professional PCB. It allows you to place individual components or planning groups. Component Explorer consists of a navigator view, allowing the creation and management of hierarchical groups, as well as showing the status of each group within layout. With each planning group, include the master board group, a list of components is displayed that can be searched, sorted, and customized by property, allowing you to organize and strategize your placement of individual components and planning groups. You can enable cross-probing within Component Explorer and the board to quickly find components already placed. The selected component cell can be previewed before placement in order to guide your placement strategy. For example, you can view netlines only between marked components for easy selection with sketch route, or to help with orienting the placement of components in high-density areas. Component placement can be completed in a few ways. Place by schematic is still an option. By just clicking on a component in the schematic, the cell snaps to your cursor in Professional Layout. However, why not take advantage of the planning groups of relational components? You can still place the components one by one, or use the Arrange dialog to place the group of components in a spiral-like fashion. Placing by group allows for optimizing floor planning. Connectivity relationships are shown between planning groups to easily visualize the connectivity flow through the design. Get a view of how the design will be connected, and plan the design's organization before any single component is placed in the design. The size of the planning group outline approximates the area of the included components, so that you can visualize if the components will even fit on the board. Placing by hierarchical subgroups, or arrange all groups based on all layers or just one layer. The subgroups can be set to be placed on specific layers and angles. The placement algorithm uses constraint editor part clearances and the part grid. Setting a subgroup up for decoupling capacitors on a large ASIC or FPGA chip is a really handy trick to control placement to minimize the rearrangement of these decoupling capacitors. Just use a larger grid to spread out the components. Although designing in 2D is standard operating procedure in most design flows, you can't design a PCB in isolation. You're designing a system. With past Professional 3D, view how the enclosure mounts to the PCB, identify complex component placement violations, and present a photorealistic product mock-up to the design team, including the enclosure. To ensure design success, a holistic view is required to look at optimizing early in the design process, the PCB orientation, component placement, and how the system is assembled. A 3D view can aid in this optimization process. A holistic design approach that left shifts design decisions early in the design cycle is required to ensure faster time to market before the system is ever physically created or sent out for prototyping. In order to streamline your design process, the same commands are available during placement in either 2D or 3D view, so that you can use the same process flow. While placing, view concurrently both the 2D and 3D representations of the part, and either drive or follow 2D view while using 3D. Connector placement is especially helpful to view in 3D to make sure you get the orientation correct the first time. PAD's Professional utilizes photorealistic solid models that can be used to verify component clearances when placing. The cell manufacturing drawing may not include all the finesse of the full 3D model, and it can be difficult to quickly visualize the orientation of a component. To ensure proper clearances between components, set up global and custom clearances between the specific objects and components. Perhaps a connector needs extra space on one side during insertion that is not represented in the mechanical drawing. By viewing the design in 3D, one can visualize how the PCB could be assembled or interfaced with. You are also running DRC verification checks before the system is ever physically created or sent out for prototyping, potentially reducing time to market by left-shifting electromechanical issues earlier in the design cycle. When interfacing with other members of your team in manufacturing, it is best to come prepared with a visualization of the design. PAS Professional makes it easy to view the design in 3D with photorealistic solid part models, while showing off internal layer routing and fan-outs. Have complete control over what you see and reduce render time by turning on what is only essential. You can even extend the Z-axis of the board to look at through-hole components and their interaction with the internal structure of the PCB. Measuring is a simple right mouse button click away, making it easy to quickly measure between objects in order to check against potential clearance and assembly issues. Double-check connector placement in regards to the assembly and component offset from the board edge. By simply clicking once on the object of interest, the measurement tool automatically snaps to other objects when moving the cursor. Remember, you're checking the design before the PCB is sent out for prototyping, allowing for extra passes of verification. The purpose of all this is to minimize rework by catching placement or part choice problems earlier in the design cycle. Also, present your board outline with its 3D representation with 3D PDF or export the entire board as a step model. PAS Professional is designed to reduce the number of mouse clicks when routing while simultaneously increasing the quality of routing with push and shove routines. The routing algorithms are designed to reduce rework by minimizing the number of meanders, jogs, and trace segments. This is achieved by implementing advanced gloss built-in routines. One of my favorite features to use when routing is the active clearance dialog. The active clearance bubble shows a blue shadow of the actual clearances around your cursor while interactively routing in real time. The clearance keepouts are easy to see while still providing enough transparency to not be distracting. Active clearance provides a quick visual feedback of available routing paths. It is also extremely helpful in identifying the clearances of objects that will prevent a trace from entering a tight space. Active clearance will reduce your frustration level in highly dense areas when traces just won't go through. Interactive routing supports 4 routing methodologies. We have real trace delayed, the recommended mode. Simply click once to start. If a path is blocked, the route will enter a shadow mode until the trace reaches open space and a valid push and shove routine is able to be completed. For large bundles of nets, this minimizes the amount of traces attempted to be pushed and shoved when interactively routing, and ends up increasing trace quality while reducing mouse clicks. I've also noticed in extreme cases of net density, this algorithm helps to improve performance by holding off on the push and shove routines. Next, real trace dynamic, where push and shove is dynamic and the algorithm does not wait for an opening to push. Like real trace delay, there's no need to click to auto-finish the trace, saving time, by simply hovering the cursor over the target pad to auto-complete the route. This is a very powerful mode, and if you're not careful, you can overly push and shove traces. For complete control, there's hockey stick mode, albeit with a lot of clicks. One click for each segment with local gloss to smooth out and reduce unnecessary joints. Click on a previously laid traces to go back. Also, hockey stick mode supports curve routing mode. This routing mode is extremely helpful in routing exact traces with anchor points, especially with coplanar waveguides. Segment on click is very similar to hockey stick mode. It supports any angled traces as well as curve routing. The purpose of Sketch is to empower you with advanced, easy-to-use automation to route high-density, high-quality routes. The automation is in your hands to control and finesse. This is not an auto router, it's user-assisted automation. You can quickly route groups of netlines in a high-quality manner. Just draw a sketch, a simple object to control the trace path, decide which netlines to route, or let the algorithm decide, set the layers, via patterns, and the style of routes. Sketch Router can be applied to a wide range of conditions, including large groups of netlines, or smaller groups of associated netlines that start and end in the same general area. There's a multitude of methods to get started. By simply drawing a sketch path and hitting F9 to sketch route, the algorithm will automatically select the netlines to route based on proximity of the start and end points of the sketch path. If you want more control, you can select the netlines of interest before drawing your sketch. You can sketch route in two styles, packed and unpacked. Packed, packs the routes as closely as clearances are set, using gloss to minimize trace segments. You can add meandering by drawing a longer sketch path, as the algorithm will follow the sketch path more closely than unpacked. This is useful for tight bundles of nets when you want to minimize free space entering or exiting the highly dense BGA. You should consider using the unpacked style if you're seeing unnecessary trace packing or hourglass shapes. And if you plan on doing manual tuning, you should consider using the unpacked style because the traces will be spread out. When using unpacked, the algorithm prioritizes reducing segments as opposed to packing the routes along the sketch path. By default, the sketch path is freeform. You may choose an angled sketch path using F10 toggle sketch style or right mouse button click toggle sketch style. The freeform path is best when you just want a quick path through a general area. The angled path is best for precisely placed straight paths with more specific control over meander and bend location. The routes tend to adhere more closely to an angled sketch path. Sketch is so fast, you can quickly undo and redo the routing. Use Sketch as a what-if scenario. Sketch empowers you with intuitive automation that is under your control. If Sketch is used in conjunction with routing tools and applied to the appropriate conditions, total routing times can be significantly decreased without sacrificing quality. High-speed memory interfaces and other sensitive connections multiply design complexity. Designers need more advanced tools to meet tighter and tighter constraints. The PAD's Professional Multi-Trace HSD tuning option offers high-speed design features and automation to reduce design time by quickly defining, tuning, and reviewing complex nets. Multiple methods for tuning traces in your design are provided to quickly match lengths of high-speed routes. With the target length dialog, view constraint-dependent nets by selecting one net. Sort and view the longest net of the bunch to plan your attack. Cross-probe and select your nets of interest for manual tuning, or tune the bunch using auto-tune. Auto-tune uses the constraint definitions, providing a one-button tune that meets electrical delay requirements, enabling you to minimize rework and ensure your design will meet the most stringent timing definitions. Manual tune gives the designer more control to precisely add length to meet the most complex constraint definitions. Open up dense areas of the board to add length to traces where needed, while preserving existing tune structures. PAD's Professional comes with optional advanced RF functionality to tackle today's challenging multifunctional PCBs. More complex designs containing multiple different frequency RF blocks, highly sensitive digital and analog systems are all tightly compressed on the board, and they're becoming more commonplace. A tried and true method of laying down smart RF shapes that are parameterized and simulated in industrial standard RF design simulators is essential for design success. Don't waste time laying down dumb copper. Use a tool that understands that physical connections are not always a short circuit, contains smart clearances, and parametric descriptions that can be simulated. Don't manually export or import Gerber for simulation. The built-in synchronization wizard directly translates your RF design into Agilent ADS or National Instruments AWR, saving critical setup and processing time. This allows faster design iterations by changing, checking results, and changing again. RF circuits can be bidirectionally transferred to Agilent ADS or National Instruments AWR using the integrated link, eliminating manual data transfer and syncing for quick and easy simulation. Start the design in PAS Professional or ADS. You can quickly connect RF nodes with meanders or curves. Let's move this RF microstrip line to add a meander. Using the key-in command, move selected and input a delta X. With the Add Meander dialog, let's add a manually defined serpentine, leaving the corner type as free radius to add curved miters. We could use miter here. Just click on the RF segment to start laying down copper. Each RF shape is parametrically described and can be edited. In this example, a miter segment is widened and the sweep angle changed on a microstrip radial stub. Just double-click on the segment of interest. Shield vias can be easily added to complex outline geometries with the Add Via dialog. Use Ctrl-V to open up the Add Via dialog using Stitch Contour with 2 rows of vias. Select the net name to be assigned to the vias. With the shape selected, just hit Apply. Custom clearances can be easily defined by the RF group using the RF group clearance editor. In this example, let's increase the plane to RF shape clearance. After hitting Apply, notice the plane data is dynamically updated. To control the exact copper shape clearance through the Z-axis of the board, more clearances can be defined. In this example, let's change the plane clearance to a slightly smaller value than the same layer clearance so that we can see the change. The pink plane layer on layer 2 now has a clearance applied, exposing the green plane on layer 3. Another handy feature is the auto-arrange RF command. When placing RF shapes, don't bother connecting each segment, just hit auto-arrange to build the RF shape based on the schematic. The RF symbols are also included in the install. These symbols give the users a quick way to create parameterized shapes as a reference or use them as is. These ADS parameters are used to build the simulation model. These RF elements can be cross-probed between the schematic and layout. Market drivers of thinner, lighter, and more complex systems are driving the growth of flexible technology usage. The ability to fold, snake, and bend around an enclosure opens up the design space, so that the entire system is now open up for review and optimization, increasing the product's strategic competitive advantage, though you're left with how to visualize and manage the complex interaction of boards and assemblies. Mentor is here to help with the PAS Professional Flex support starting in VX.2.4. Quickly visualize complex bends and the board integration with the assembly. Verify that bend areas are valid and that no part or connector interferes with something else in your complex origami-like circuit. A flex design requires a master stackup consisting of all layers to be used in the design. In this example, I have previously defined a flex cable with a top cover layer, a plane layer, a polyimide flex core, a signal layer, and a bottom cover layer. The cover layer aids in copper adhesion and scratch protection. Once the master stackup is defined, individual board outlines can be assigned their respective stackups from the master stackup. Stackups can overhang as long as they don't share common layers. Each board outline will have an associated route border that is used as a render fence for the plane data and as a trace keep out. To quickly generate the route border, a built-in tool is provided, Draw Generate Route Border. Next, let's define the flex region that will flex with defining a bend area. Go to Draw Bend Area. Let's add the 3D view to visualize the bend area. 3D visualization becomes key to identifying component placement and clearance issues earlier in the design cycle and is essential for faster time to market. This concludes this brief introduction to the PAS Professional design flow, covering the advanced features and necessary options in today's world of highly complex multifunctional PCBs. We covered the advanced GUI and display control settings that will speed up your day-to-day workflow, floor planning and placement management to avoid the old way of distributing parts outside the board, the benefits of 3D placement, and making sure you are aware of electromechanical clearance issues earlier in the design process. The autoactive routing algorithms of PADS Professional will aid in faster completion times with less rework due to jogs and meanders. The RF license will aid in streamlining your simulation and design flow with Agilent ADS. And lastly, use the Flex license to manage, view, and verify complex bending and assembly interactions.
Okay, so that concludes our webinar today on the PADS Pro. Should any of you have any questions or want to get your hands on our tool, please give us a call at EDA Direct. Our salespeople will be happy to get you set up with an eval guide. And so that concludes this today. I want to thank everybody for joining and hope to hear from you soon. Bye-bye.